Hey there, this is the video for Chapter 9, Section 2. There are a few tough formulas this time, but we'll walk through them a step at a time. And we'll go over some handy calculator shortcuts, so make sure you take the time to get those down. This is a short one. I know you'll do great. Let's get started. Welcome to the lecture video for Chapter 9, Section 2, Linear Regression. Today we're going to learn how to find the equation of a regression line and how to use the regression equation to predict y values. Picking up from where we left off in Section 1, after we have verified that the linear correlation between two variables is significant, you'll then be able to come up with an equation for the line that best represents or models that data. This line is called the regression line. It can be used to predict the value of a y for a given value of x. These values are the y hat values that come from the regression line. Here are the data points relating two variables to each other. Through them is drawn the regression line, or the line that best models the data. For every data point along this line, there is a value d sub I that represents the difference between the observed y value and the predicted y value, or where the y value would be if it aligned perfectly with the line. This is done for every x value. These differences, or d sub I values, are called residuals, and they can be negative, like these are, because they're below the predicted y value, or positive, like these are, because they're above the predicted y value, or zero, which would be if it was exactly on the line. The regression line always passes through this point where the x-coordinate is the average of the x values and the y-coordinate is the average of the y values. The regression line is also sometimes called the line of best fit. It is the line for which the sum of the squares of the residuals is a minimum. This means that it is the absolute shortest distance between all the points and still a straight line. In algebra, the equation for a line is pretty simple. Y equals mx plus b, where m equals the slope and p equals the y-intercept, or where the line crosses the y-axis. Well, for a regression line, we have a similar formula, except we're using y hat, and it stands for the predicted y value for a given x value. The equation of a regression line for an independent variable x and a dependent variable y is y hat equals mx plus b. The components of this equation, the slope and the y-intercept, are found with these pretty complex formulas, but we'll take them in bite-sized chunks. Y bar is the mean of the y values in the data set, x bar is the mean of the x values, and n is the number of pairs of data. So if it asks us to find the equation of the regression line for the gross domestic products and carbon dioxide emissions data from a previous problem, we just need to find the pieces of those component formulas and then plug them into the formulas. So here is the data from that problem, and here are the pieces we need for those component formulas. Let's use our calculator to find each one. To begin, we need to make sure we know where the data is within our calculator. Hopefully you still have it in two of your lists, like L3 and L4. Check your calculator by pressing Stat, then Enter to find out. If you do not have them entered, do that first. The GDP data in the first list and CO2 emissions in the second. Once you've verified that you have those in lists, one place we'll need to get a few pieces of information is from the one variable statistics function. We can do that for both the X and Y lists to get similar results for both. Let's see what I mean. Do you remember how we reached that before? You press Stat, then arrow over to Calc, then press 1 or Enter 1 for one variable stats. Then verify that your first list is the one indicated, and press Enter enough times for it to calculate. Now we look for some of our results. So one variable stat function gives you information about the list you give it, like sample size, mean, some of the items in the sample, and some of the squares of the items in the sample. We can use all of those in the formulas. So what do we have? First, n equals 10, the sum of the x's is 25.7, the sum of the x's squared is 82.81, and x bar is 2.57. Now we switch it up and do one variable stats on the y list. So press Stat, arrow over to Calc, and press 1 or Enter, and this time change your list to the second list you have. So it's going to be the Y list. You may have to choose from lists, or you may need to press the second button and a number on your keypad associated with a list, like second 4 for L4, then press enter as many times as needed to calculate. Now we look at our results for this list. We don't need as many of the results for this one. The sum of the Y's is 5269.5, and Y bar is 526.95. Remember, even though it says X bar on your calculator, we're doing this function for the list we have that is representing Y values. Okay, so the way we're going to get this last one is we're going to go back to the main screen with second mode if you're not there already on your calculator. Then we're going to multiply the two lists from here. When it does this, it multiplies each item on one list with the item on the other list, which is exactly what we need done. Then we're going to run one variable statistics on that resulting list of products like we did before to get our sum. So first we need to multiply the lists. We do this by pressing second and whatever number on the keypad aligns with the first list you use for this problem. I used L3 and L4, so I would do second 3 first. Then you press the multiplication key, then second and the second number for the second list. I'll press 4. Then press enter, and it shows you a set of the new list created with those products. Now before we can run the one variable stat function on it, we need to store this new list somewhere. So we press the STO button with the little arrow right above the on button towards the bottom of your calculator. Then press the list number. You don't have anything in yet. I'm pressing 5 on mine. Now we can perform the one variable stats function on that new list. So we press stat, then arrow over to calc, then press 1 or enter, then put in the list number for where you stored this new list. I have to press second and 5 because I stored my new list in L5. Then press enter as many times as needed to calculate. Then you should have a sum. You should come up with about 16,687.99. Now that we have our numbers, let's calculate these formulas. We just need to substitute in the proper values. So we have 10 times 16,687.99 minus 25.7 times 5269.5 divided by 10 again times 82.81 minus 25.7 squared. Be careful when you're entering this in the calculator. I put a note here with the most cautious way you can enter them with parentheses around everything. I essentially put one set of parentheses around the numerator, then another set around the set of products on the top and bottom. You also want to be careful in your substitutions on the bottom of your ratio. The first term is already x squared. It's the sum of x's already squared. The second one is squaring the sum of just x's. So make sure you have that straight in your notes or see that clearly in the lecture notes. Pause for a moment and try this one on your own. Okay, so we get about, because we're rounding, 187.6603. If you didn't get that, go back and make sure you had parentheses in the right place and were careful of the decimal places. When I'm entering an equation fast, I sometimes accidentally press the decimal instead of 0 or things like that. Okay, next let's do the y-intercept, or b. So we have y bar is 526.95 minus 187.6603, which we just came up with, times 2.57. Pause the video for a moment and try this formula on your own. So we get about 44.663. Now we have the slope of the regression line and its y-intercept. So the equation of the regression line is y hat equals 187.666x plus 44.663. Great job. Now, good news, you don't have to go through all of that every time. You can use the tool we discovered last section, the linear regression function, on your calculator. You still have to enter data into the two lists. I have mine entered into L3 and L4, but you can use the function instead of doing all the rest of the work by hand. Okay, here is how to do that. Enter the data into the two lists, then press Stat button, arrow over to Calc, arrow down to or press the For Linear Regression AX plus B selection. Put the correct lists in for your data, L1, L2, or L3, L4, however you have them entered. Then press Enter as many times as needed to calculate. A will be your slope, and B will be your y-intercept. Wasn't that much easier? If you were following along, you should have come up with the same numbers, but maybe with more decimal places. Okay, so remember how we drew a scatter plot before? It just showed us the points, but we didn't have the regression line. Well, now that we know what it is, the regression line, let's place the regression line among the points. Here's how we do that. First, we turn on the diagnostics. Well, we did that before. They're already on, so we don't need to do that. Next, we draw the scatter plot. Do you remember how to do that? We press the second button, then Y equals button. Make sure the number 1, plot 1, is turned on. The way you do that is to highlight the on and press enter. Then press enter. Then make sure on is selected on the next screen. Then you want to make sure that the type of graph selected is the scatter plot, which is independent dots. And that's the first graph. Then arrow down and check the X list and Y list. They should have the lists you're currently working with. And you may have to select them depending on how your calculator does that. If all is good, now press zoom 9, and that will show you the scatter plot with just the points. Now we get to the part where we're adding the regression equation. We have to add the equation to the Y line so the calculator knows to graph it. We do this by pressing Y equals, then pressing the vars button, then choose or press the 5 statistics selection, then arrow over to the equations or EQ menu, then press 1 or enter, and lastly press zoom the number 9, and it should graph the regression line through the middle of the points. Cool, right? So why are we doing this? We are coming up with the regression equation as a way to predict values of y that were not part of our observed data set. So if I want to know what the response to a certain value of x is, I can just plug that x value into the regression equation, and I get a predicted value for y for the response variable. For the observed data in the last example about GDP and CO2 emissions, x ranges from 0.9 trillion to 5.4 trillion. So it wouldn't make sense for me to try to predict the carbon dioxide emissions when x is 0.2 trillion or 14.5 trillion. These observations are very far out of range from what has been observed so far. The regression equation is only meaningful for values that are within the range of what has been observed and recorded before. I can't go below 0.9 or above 5.4, but anything else within that range that's already been recorded and observed that I haven't already observed specifically, I can put in an x value and predict a y value for that x. You can do this by hand and just substitute this value in for x, but let's look at a way to do this with our calculator. Press second button, then the window button, then arrow down to where it abbreviates the word independent, and you need to arrow over and select ask, then press enter. Next, press the second button again and the graph button up above. This takes you to the table where you can enter an x value and the calculator will enter it into the regression equation you entered into the y equals before. So when you get to the table, type in an x value and press enter. It will give you a y value. Press enter and repeat the process for the next 2 x values. So make sure you got all the formulas and the calculator notes for this section, so you'll have them handy for the combined Chapter 7 and 9 quiz and for the final. You're getting close. Doing great. You're almost there. Just one more section. I'll see you on the next video.